In this video, we're going to be solving equations again, but this time the variables are going to be on both sides. So the first goal is to get the variable onto only one side. So when we look at this question here, we have an x on both sides. We have this 5x here and this 2x here. The easiest way to get all the x's on one side is to subtract them away from one of the sides. So we can just subtract 2x. Sorry, I don't mean that to look like a division here. Let's get rid of that. So we're going to subtract 2x from both sides, and then we end up with 3x plus 2 equals 14. Now we can just solve it as a normal two-step equation. We can subtract 2 from both sides, and that gives us 3x equals 12, and then we can divide both sides by 3 and get x equals 4. As usual, you should double check to see if that solution works. So we get 22 on this side, and 8 plus 14 is 22. So this is correct. All right, let's try some more. Here we have a similar situation. We have the p on both sides. Here we have decimals, so that might make it a little more difficult, but it shouldn't. So I'm going to subtract 1.25p from both sides. So 1.5 minus 1.25, well, if we want to, we can do this over here, but I think it's going to be 0.25. Yeah, so we have 4, 10, so we have 0.25p equaling 8. And now we're going to, oops, I should have done that in blue. Let's try that again. Alright, we're going to make that blue. Yeah, no problem. Okay, so now we're going to divide both sides by 0.25. Remember, when you divide by a decimal, it's actually going to make the number larger. So p equals, so 8 divided by 0.25 is actually 800 divided by 25. 25 goes into 100 4 times, so it's essentially going to be 8 times 4, so it should be around 32. We can double check that here. That'll go in 3 times. Yeah, 32. Alright, so p is going to equal 32. We should double check that. At least, at the very least, we can estimate it. So 1.5 32s, that should be, I think, 48, equals 1.25 32s, which would be 32 plus 8, which would be 40, so 48. So that is correct. That makes sense. You can go so far as to actually do the whole calculation on here. If I was taking a test and I had enough time, I would. If I was taking a test and I didn't think I had enough time, I would for sure estimate it like I just did there. Your estimation ability will get better with use. Okay, here we have another question. The variable is on both sides at the beginning. We have a 5x and an x. We can't just subtract an x here because this 3 needs to be multiplied by it. It's not really an x, that's actually a 3x. So this will not work. So we're going to not do that. So the first thing we're going to do is distribute the 2 here and the 3 here. So we're going to get 2 times 5x, so we got 10x, and then 2 times negative 1 is negative 2, or minus 2. Over here we'll have 3 times x plus 3 times 11. And now we can start getting the variable on one side. We can subtract 3x here, and that'll leave us with 7x minus 2 equals 33. We're going to add 2. So 7x is going to equal 35, and now it's pretty obvious. Looks like it's going to be 5, so x equals 5. Again, we can do our little double check here. So 24 times 2 is 48. And we got 16 times 3 is also 48, so that is correct. moving on. Kind of a mix of two previous examples we've done. We have distributive property happening here and just the regular stuff over here. So let's do the distributive property. We're going to get 10x plus 12 over here. We have 10x plus 12 over here. So you might see what's going on already, but rather than guessing at it, I'd like you to continue solving it as you would normally. So to get the x's out of one side, we're going to subtract 10x, and look what happens here. We're going to get 0 x's, so we'll have just 12, and we're going to have 0 x's over here and just 12. And so this is an interesting answer. Don't freak out, because this answer means something. Whenever the variable disappears through your manipulation, or through our manipulation, a couple things can happen. In this case, we get just a number, 12 in this case, equaling another number on the other side. And these are equal. This is a true statement. 12 does equal 12. So what does that mean for our variable? How have we solved this? Well, it turns out that the expression on both sides of the equation is the same. So what we're saying is, this equals this, and it actually does. It's the exact same thing. So x can be anything. And whenever you get a statement like this, I recommend you always plug in two different things. So plug in something easy like 0. So 0 plus 12 is 12, and then here we have 0 plus 6 times 2 is 12. So 0 works. Try something else easy like 1. So 10 plus 12 is 22. 11 times 2 is 22. So it works. So what we call this is called an identity, and we say that it is true for all real numbers. Okay, so there's an infinite amount of correct answers, so we just call it an identity. Alright, let's see what happens in this problem here. Again, we have variable on both sides. In this side over here, we have 2. So we can start by combining the like terms. So we have 9m minus 4 equals, and that we have a negative 3m and a positive 12m. So I should underline that whole thing. So we have a 9m plus 5. Now we want to get the variable on one side, so we're going to subtract it from one of the sides. So we're going to take away 9m from both sides, and then on the left side we get a negative 4, and on the right side we get a positive 5. So it's very similar to what happened last time. I'll go back, where the variable disappeared. So that happened, the variable disappeared, but this is a not true statement. Not true. So it's different in the sense that negative 4 does not equal 5, so we can say phew. So what happens here is there's no solution. So don't freak out that the variable disappeared. That's totally fine. It just means that there is no possible solution. No number that you can plug in for m would make this a true statement. It's just not possible. So again, we get to this area by just solving for m like we normally would. It just turns out that when we try to eliminate the variable from one side, it gets eliminated from both sides. So we end up with a not true statement. No solution. This would be the way you answer it.